Okay, today we're going to look at another continuous distribution. So like normal distribution, it is continuous, but this time it's uniform. So there's no peak. Everything in it has exactly the same chance of happening. So it looks like a flat tabletop. It's called a rectangular distribution. So that's a little diagram of what it looks like. So a few things we need to know about it. It's a continuous distribution. It takes the shape of a rectangle. So the probabilities are the same for all intervals, all equal intervals. And we need a maximum and a minimum, but no mode. So the next one we're going to do is triangular. It'll have a mode. You know it is a rectangular distribution if they give you a maximum and a minimum and no mode. They might say everything's equal chance of happening, but it's key that there's no mode. So an example would be a tug of war rope is equally likely to break at any point between the opposing teams. So the equally likely part tells you it's a rectangular distribution. Okay, so if we look at the diagram, what we have here is we have the lowest value the distribution can take. So for example, in the time waiting for the bus, it might come between 9 and 15 minutes from now. So this would be 9 and this would be 15. So it's the lowest value the distribution can take, and this is the highest value distribution can take. And over here we have the height of the distribution. So that height helps us work out the probability. Now, this little formula here is telling us how to find the height. 1 over b minus a. I'm going to explain why. So a rectangle is really easy because with a normal distribution, what we're doing is we're finding the area under the curve, but because it's such a funny shape, we can't find it very easily. But with a rectangular distribution, we can find the area under the curve because it's a rectangle. Now, just like in normal distribution, the area under the entire curve is 1. 100% represents everything. So again, my area is going to equal 1. Now let's just say, for example, the base of this rectangle was 10. Now if the base of this rectangle is 10, I need to work out the height. So I know area is equal to base times height. So my area is 1, and that's equal to 10 times my height. Now I have to think what times 10 is going to give me 1, and it's going to be 1/10. So I know the height would then be 1/10. So that distance, the formula b minus a. So if this was 5 and this was 15, that would give me a base of 10 because it goes from 5 to 15. Yep. So what the rectangular distribution might ask you to do is work out the probability of some smaller range within the entire distribution. There are two ways to work that out. I'm going to show you the other way on the next page, but they've given you a formula here. Now it's not on your formula sheet. So they're giving you a formula here, and that is the distance of this divided by the distance of this will give you the probability that this is going to happen. Because you're saying this much out of the entire thing. So if this was 5 and this was 15, then again my base would be 10. And if this value here was 7 and this value here was 10, my length here would be 3. So my probability of this section would be 3/10 because it's 3 sections out of the 10 sections. And then to work out the mean of a rectangular distribution, the average, it's just the middle value. So if my top value is 15 and my bottom value is 5, my mean would just be 15 minus 5, which again gives me 10, and half of that divided by 2 is 5. So my mean is just half of the distance here. Okay, let's have a look at the first example. So it says a company requires that all employees work for 40 hours per week, of which a minimum of 10 hours must be spent in the company office. They're very lucky to have spent 10 hours in the office. The remaining can be spent working from home. So they must spend a minimum of 10 hours working in the office, a maximum of 40 hours working in the office. It says calculate probability that an employee spends less than 15 hours in the company office. So we're starting here at 10. I hate that it zooms out whenever I try and do the pen. So we're starting here at 10 and we're going to 15. That is a distance of 5. And my total distance, it can be between 10 and 40. So that's what they've done here, 30. Don't need to do it again. So there's 30 here. So it's 5 out of 30. So the probability they spend less than 15 hours is 5 out of 30. Now it's really important that we do work out the height as well, because often they will ask you to work out the height. So the height, remember the area is 1. Here it is 30, so I know my height is equal to, my area is equal to base times height. And so my area I know is 1, and my base is 30. My height I currently do not know. So to work out height, it's just 1 over 30. So it's always just 1 over the distance here. So I can just write 1 over 30 here. You don't need to change it to a decimal. You can just leave it as 1 over 30 here. Now the other way to work out the probability is, you know the distance here is 5. So you can just do base times height. 5 times 1 over 30. Because you know your height is 1 over 30. So you can go 5 times 1 over 30 is another way of doing it. And you get the same answer, 5 over 30. Because I know my height is 1 over 30. I know I've got a base of 5. So base times height gives me the same solution. Okay, I want to show a way that's a little bit different to the book. So you can look at the book example, but I want to show a way that I find much easier to understand and deal with the algebra. So like I said, the height over here is 1 over 30. We can leave it as a fraction. Now it says 20% of employees who spend most of the time working at home do not qualify for a desk of their own. So that's the top 20%, and they've done a shaded in this part to tell you that's 20%. So they don't know the value that starts at. So what is the maximum length of time that an employee can work at home each week if they wish to qualify for their own desk? So I want to work out the length of this, the base. To work out how wide that is, and however wide it is, I'm going to take it off 40. So I know that area is equal to base times height. Now I know my area, I want it to be 20% of the employees. So my area is 0.2. That represents the area of the shaded in part, 0.2, 20% of the employees. My base, I currently do not know. I'm trying to work out my base, so I'm going to leave it as B. And my height, always work out your height first, which we did in the last question, is 1 over 30. Now we need to know a little bit of algebra. I want to get B by itself. This is times 1 over 30. To get it to the other side, I need to divide by 1 over 30. So 0.2 divided by 1 over 30 equals B. So I do this into my calculator. 0.2 divided by 1/30 equals 6. So that tells me my B equals 6. Now that's just the width of this part here. So if this is 40 and this has a width of 6, this Y value is going to be 40 minus 6. So Y equals 34. So they must spend, maximum time spent working at home is 34 hours a week. So I only have to work it. Maximum time spent working at home is 34 hours a week. Okay, I'm just rereading this question. And maximum time working at home is 34 hours. Does not make any sense because they have to spend at least 10 of their 40 hours working at home, in the office, which means anyone maximum time working at home is 30 hours. This grey part here represents how much extra time they spend working in the office, not how much time they spend working at home. So this example isn't quite right. Okay, what I think the actual answer should be is this here, B is equal to 6 is still important because that still represents 20% of my distribution. But actually, I'm looking for this value here, the 16, because these people are only spending 10, they're here, they're only spending 10 hours in the office, the minimum. And these people up to here are not spending that much time in the office, and that's the point of this question. They're not going to get a desk if they're not spending much time. So we actually want this bottom bit here. So that gives us 16 up to here. Now that's telling me the amount of time they're spending at home, in the office, sorry. The amount of time they're spending in the office is only 16 hours. The question asks what's the maximum length of time employee can work at home each week. So if to be in the people that are spending the most time at home, they have to be spending the least time in the office. So they're spending 16 hours in the office. How many hours does that mean they're spending at home? 24 hours. The answer is 40 minus 16, which equals 24 hours. That should be the correct answer. I know that was really confusing, so I'm going to do the other examples in a new video.